The Minakshisundaram Pleijel zeta function is a function that arises in the study of spectral geometry, a branch of mathematics that investigates relationships between the geometry of a manifold and the spectrum of its Laplacian operator. This zeta function is named after the mathematicians Subbaramaya Minakshisundaram and A. Pleijel, who introduced it in their work on the heat kernel of a Riemannian manifold. To define the Minakshisundaram Pleijel zeta function, we first need to consider a compact Riemannian manifold M. This is a smooth manifold equipped with a Riemannian metric, which is a smoothly varying positive definite quadratic form on the tangent spaces of the manifold. The Laplacian operator on M is a second-order differential operator that is defined using the Riemannian metric. The Laplacian operator on a compact Riemannian manifold has a discrete spectrum, which means that it can be diagonalized with respect to an orthonormal basis of the space of smooth functions on M consisting of its eigenfunctions. The eigenvalues of the Laplacian are non-negative real numbers, and they can be arranged in increasing order and repeated according to their multiplicity. 0 lambda 0 lambda 1 lambda 2 lambda 3. The Minakshisundaram Pleijel zeta function of the manifold M is then defined as the meromorphic continuation of the series zeta ms sigma j 0 lambda j epsilon s, where the sum is taken over all eigenvalues. Lambda j of the Laplacian on M. S is a complex number with real part large enough so that the series converges. And epsilon is a positive constant that shifts the eigenvalues away from zero. The Minakshisundaram Pleijel zeta function encodes deep information about the spectrum of the Laplacian and the geometry of the manifold. For example, its special values and residues at negative integers are related to the volume, the total scalar curvature, and the higher dimensional analogues of these. Invariance of the manifold. The study of the Minakshisundaram Pleijel zeta function and its properties is a central theme in spectral geometry. This function appears in many contexts, including the heat kernel expansion, the spectral action principle, and the study of spectral invariance of manifolds. Despite much progress, many fundamental questions about the Minakshisundaram Pleijel zeta function and its applications remain open, and the investigation of these questions continues to be an active area of research in mathematics.